They want to negative and they refuse it, but if it's positive, because I didn't remember if it was positive, they're like, oh yeah, we're gonna write something down. I was like, okay, I got something.
I'm going to go ahead and start recording.
So from chapters 5 through like
The end.
you're trying to get out of it. Just don't be wrong.
No, we don't care who they acknowledge.
Oh my gosh.
What am I going to do with you?
Passing.
All right.
All right.
I know I have a whole wall of crystals.
So we're going to start with igneous rocks. We ended up with minerals the other day. Minerals are basically the foundation of rocks. You put minerals together, you get rocks. So minerals are more, I don't want to say pure because they have all kinds of different configurations. But if you were making a cookie and the cookie is the rock, the minerals would be the egg, the flour, the sugar, whatever else goes into your cookie. It's been a while since I baked. So, chocolate chips, there we go. So, the cookie is where we are right now. Igneous rocks come directly from magma or lava. And igneous, the word itself means from fire. So, I'm not sure. Deb and I used to teach this together, Dr. Himmler and I would always go forward. Look, we start with magma and we end with rocks, but she likes to start with rocks and melt them down. And so basically, I start with magma. The energy transfer, it just cools down. As it cools down, the atoms quit sliding past each other. It solidifies. In a solid, remember, atoms are packed tightly together. The only movement you have is vibration. So everything in a solid vibrates. And I posted this on supplemental materials. And so then we end up with rocks. And so there are only two ways to classify igneous rocks. They're either intrusive or they're extrusive. Oh, what does that mean? So intrusive means they form underground. They don't form above ground. Extrusive is the opposite. Extrusive, they exit the earth. They form either at the surface of the earth or from some type of explosion or eruption. So anything that forms from lava is extrusive because it happens up above. But things like granite, where it has great big crystals in it, great big minerals that you can see, that forms down below because the slower something cools, the bigger the crystals get. Up here, when this stuff cools down, you can't see the crystals. Like they're considered fine-grained. So let's take a look at intrusive. All the types of things that cool on the inside. We have things like batholiths. Batholiths are just giant magma chambers that have cooled down until they form rocks. Plutons are a little bit smaller. They're called different things, but it's based on their size.
We have all kinds of kids back here. Do you know if they were like doing something with
What?
swiping them off? She just swiped them off, but every like 2 minutes we'll have like 3 or 4 answers.
Ooh, wait, they're all over the sky.
Oh, maybe that's what it
You want to just move that one?
yeah, we can look through that. Oh, I think we're going to very better.
All right. So all of these that cool underground, they're going to have great big crystals. And by that, it just means like you can see them. You can see the different minerals with your naked eye. Like you don't have to squint or anything. You can see that there are different crystals in there. As opposed to this, which cooled closer to the surface or at the surface. This is basalt. Ooh, slippery little sucker. This is basalt. And so there's absolutely, you can't see the crystals in it because it cooled so fast. So the crystals are real tiny. And then of course, medium speed cooling, medium speed crystals.
How far underground is that stuff?
Sometimes as deep as about 3 miles. I mean, it's pretty. The neatest place I've ever been was in North Carolina at, I go to very nerdy places, but I went to this granite quarry. It was with a geology class, and we saw like how they get them up because the granite is still in the ground. And so we had to wear hard hats, and you hear this big whistle, and when you hear it, what they've done is they take these tiny little explosive caps and put them in the ground, like probably about 2 of these rooms big, in a great big rectangle. They blow this big alarm and then push the button, explosion. And I'm like, okay, nothing happened. At night, and I don't get this, like I truly don't. But at night, it takes like that long for the cracks to like give away. That whole, I just called it a loaf. This whole loaf of granite comes up about 4 feet. And then they go and they work on it and they use it for tombstones, they use it for countertops. And I'm just like amazed, absolutely amazed at how in the world they discovered that. But that's density. The density pushes, because it's higher density, or I'm sorry, higher pressure down here, pushing up, it raises it up.
What exactly is the difference between granite, quartz, and marble? Because they, when you buy your countertops and remodel, they're the 3 most expensive, and to me, with the naked eye, they all kind of look the same.
Well, if they're telling you it's a quartz, that's probably a lie. I mean, it's probably not just pure quartz. It probably has other things in it. Like, does it look just like glass?
Well, we just were in the bathroom, and for the countertop, it was quartz, marble, granite. They were all 3 really expensive, and to me, they all 3 looked the same. No, it didn't look like granite. They looked like marble. To me, it did not look.
Okay, so granite, gonna be like this.
Yeah.
Maybe with some pink in it. Marble is actually a metamorphic rock, not anything like that. It's actually limestone, you know, like what's in your driveway. Limestone that has been compressed and metamorphosed into this really hard material. And that's why they use it for countertops, because it's so hard. So it's, you know, lasts forever. They're just all 3. Quartz is a mineral, so I'm not sure how, I don't know why they do that.
Yeah, I think that's the one that was most expensive.
All right.
For someone like me who doesn't know what it is.
Maybe. So when we go through characteristics of these rocks, we're going to look at texture and the color. Now in minerals, I don't like to use color because it can change. But for rocks, it's okay. When we look at different colors in rocks, they are very obvious. Like these are 3 different colors of rocks, and that's what you guys are going to be looking at. And we're also going to look at texture. And by texture, it's not like how it feels, but it's like, okay, can I see the grains in this? Can I see the grains in this? That's the texture it's talking about. And so this one would be fine-grained, dark color. And remember what we said, the darker the color,
the more dense it is. And so what you end up seeing are all the different minerals in your rock. Sometimes it's really easy to see things like the mica. So you guys had biotite and muscovite. So the real shiny little flakes are in things like this. You'll see quartz, potassium and sodium feldspars. You'll also see calcium feldspars, but you're just able to see them in igneous rocks. And remember, we're going to go through 3 different types of rocks. Today is igneous, and then next week we'll do sedimentary and metamorphic. And like I said before, the size of these crystals are determined by how fast or slow it cools. The faster it cools, the less likely you are to see any crystals at all. If it cools real slow, sometimes you get giant crystals. But you definitely are able to see it with the naked eye. So, texture. We look at things coarse, fine, and glassy. You will also see it called vesicular. Vesicular is just a fancy geology word that means, hey, this has holes in it. And let's see here. So, of course, I didn't bring a water cup today. Anyway, so this is vesicular. And here, if I threw it back, how light is that?
It's very light.
Okay, that is so light it floats. It floats on water. So, yeah, I wouldn't throw any of the other ones. I would not want to accidentally bonk anybody. And so vesicular goes in with glassy, pyroclastic, vesicular. Glassy is exactly what it sounds like, looks like glass. Pyroclastic, it just means it formed during a pyroclastic flow of a volcano. So if lava goes directly into ocean water, you get volcanic glass, also known as obsidian. All right.
So that's probably very black.
Yes, extremely.
It's cool very slowly.
Right, and so those crystals are so close together. That's why it looks like glass, because it cooled almost instantly. And again, you're back to your magma types. And so fine grained can be rhyolite or the rhyolitic magma. Rhyolite is the rock, comes from rhyolitic magma. It's extrusive because it comes from an eruption, usually from like a super volcano. Andesitic also, sometimes we can see the grains, but not often because that is also explosive. And then basalt, the very, very dark colored rocks. Today, you'll figure out the difference in the coarse grained ones. You'll have granite, diorite, and gabbro. So this one will be very light colored, medium colored, and then this one is going to be dark, usually with some olivine or pyroxene. This will have like dark greens in it and black. So, and we already went over the Bowen's reaction series. And I think we are ready to go ahead and look at our lab. Absolutely, yeah. All right, so get out your little chart. Hopefully you guys have, let me see here, 1, 2, 3, 4, 5, 6, 7, 8, 9 rocks. If you don't tell me, because I've got a lot of extras up here.
You want this rock
Yes. Good shot.
Do you know what I mean? Yes. Don't like that very well. One color is in the middle.
Now remember, you're gonna have to be able to see the, you have to be able to see the grains for it to be large crystals. So I think you had it right first time.
Yeah, this one's good.
Yeah, that's that one.
On that one. Then it's dark.
And that's dark, and can you see the crystals in that one?
This one's kind of
Some dark, small crystals.
What's up with there?
Oh, okay, I didn't realize.
It's like white crystal.
Maybe that one has holes.
Two that are the sick
Like
one.
a hole.
One's
I
gonna be
think she
light
said
colored,
that.
one's gonna be dark colored.
I think that might be Thomas.
And then you go up to the
Yeah.
light with the medium.
I don't know about that.
This is large. You can see
Wait, this is.
I'm sorry. This one has.
No,
I think that one has holes, so. Yeah.
You want to put this one here? This one here?
I think that's big one. Now, what about granite that I see that is like right? Because I think this one right here needs holes.
So this one go here?
Got it.
I mean,
I don't know about that. The mineral? Yes. That one I don't know. I like.
I do see that.
So now that's dark.
Oh, that one is the sick one. That one. Oh, no.
What do you think? Assignment? I don't know. Of course.
Yeah, we have to try over. We have to try.
Right.
And it has to relate to a project.
What is that?
This one, for whatever reason.
At least it's just.
This light is right. This one, yeah, is right. So this comes from like.
I know.
Yeah. And this one's the
So we can have all members.
All right, you
So-
guys good? Let me see.
All of us.
So what do we?
Okay.
There's no assignment today.
Oh, so we don't have to take a picture of this? Yep, just take a picture in case I have to say, hey, were you here? And you can be like, hey.
Is this right?
So that's it? Yep, I'm gonna go over Survivor real quick and you're done.
We didn't know what the.
Oh, shoot. And remember, this is the big crystals.
It's like
You're close.
Yeah, you are.
Only have three though.
So,
Okay.
the large crystals have to be the ones that we see, and that's in the correct order. That's good. Now you're right. So take a picture just in case. Yeah. So you don't actually have to turn anything in, it's only if I were to have attendance questions. All right, so Lacey, they just finished the lab. Let me stop sharing this. They just finished the lab that had this chart. I'm going to share it with you. And so really, igneous rocks are pretty easy to tell apart. Large crystals, I want you to think about what you've seen on countertops, like granite countertops. the granite, the diorite, and even the gabbro is just a light colored granite, like mostly white and black. Diorite has like white, black, pink, maybe more black than the other one. And then gabbro has like dark green, black, and a little bit of white. And then rhyolite is just a light colored rock. Andesite is gray, basalt is dark. And then pumice, I think you've probably seen pumice like to scrub. Yes, it's like your foot scrub. That's honestly what they use. And then scoria, we all probably call them lava rock. You'll see them in grills. You'll see them outside as decoration. And obsidian is just volcanic glass. All right, the last thing for today is survivor. Oh, whoops. All right, let me share this screen. Okay, so get out your survivor. This is highly modified. Like I took off a ton of stuff because usually survivor lasts a month, but that just wasn't going to happen between COVID and then with me being out. So you get a modified survivor. You can have up to 4 people. They don't have to be in this group. They can be in the other group. Up to 4 people in your group. You are going to be observing weather for 1 week. I would start today. Percentage of cloud cover, 100%. Weather, rain, and so you have to take a picture of the weather every single day at about the same time. Right. So if it's easier in the morning, go outside, click, be done. So you're going to find a team. You're going to give your tribe a name. It has to, more creative, the better. It's only worth 5 points. The first step is figuring out the meaning of your science language. And so you will see the language that I have for you. You're going to prepare. This whole thing is going to be turned in as a PowerPoint. So like your first slide should be, survivor project. Second slide, team name, team members. Why did you pick this name? And then 1 slide per each word. I'll come back to your observations. Like you're going to tell us what temperature means. What's a high temperature, low temperature? Barometric pressure. What does pressure mean when we're talking about weather? Not like, gas laws, but even though it does relate to that. You're going to have to figure out cloud types. So light and fluffy doesn't cut it. So you will find they have really good cloud type identification guides online. Just download one, match it up. Wind speed, wind direction, percent cloud cover, humidity, and precipitation. Like 8 slides for that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I separated temperature highs and lows to 2 different slides. Okay. If you put them in the same, it's fine. Okay. And then I want you to make sure on each of those slides, what kind of weather instrument measures each one. So remember, this is for like 5th grade kids, so 10-year-olds. So if you're talking about temperature, include on your slide a nice little picture of a thermometer. If you're talking about wind speed, include on your slide a picture of an anemometer or a windsock. No, anemometer, because it actually measures the speed. Precipitation, do a rain gauge.
So the definitions, do they have to be like
5th grade level? Yeah, don't tell me that, like, I know the definitions. Just like you're going to practice giving it to like a 5th grade kid.
So it's kind of like a lesson.
Yeah, just a little tiny little one that I'm really guiding you through. All right, so you're going to construct a template for recording weather. By that, I just put a table down. Find a table for recording weather that you would use for a 10-year-old. Okay, so it needs, I'm sorry, that's me, somebody's emailing me. So it needs to look, like something that a kid would like to do. And you're gonna make sure it has like room for the date. What time is it? What is the weather? What's the temperature? What are do you see any clouds? What do they look like? So find a template that matches up with a 10-year-old. I'm not going to assign you one single template. It's up to your group. Locate and print cloud identification chart. Included as part of your PowerPoint. This is the chart I used. So, and then part D, you're going to collect data for 7 days. It's going to tell me the weather, tell me the temperature, tell me everything you can find each day. Now, these pictures will go in your PowerPoint as well. Your whole presentation, this whole survivor is going to end up as a PowerPoint submission to me. Like, I'm not going to have you build anything. We
I have a
just,
question.
yeah.
It says that each member does their own data collection.
Oh, that's a lie.
Oh, okay. I was gonna say, so do we have to have like 3 or, everybody's pictures in there or just one?
No, just you guys agree on, hey, I'll do it this day, you do it that day,
Okay.
and then just combine them. Because I know we're getting to the end of the semester and I know you guys have a ton of stuff to do. Then the final part, almost the final part. So part E, you're just going to answer these questions. And I don't care how many slides you break that down into, you're just going to answer the questions. And yes, don't cut and paste from the internet, just paraphrase. And then the very final data analysis slide is just going to be like, what do you notice? What relationships are there? For example, if I notice that we have a low pressure system moving through, does that mean it's going to rain or does it mean it's going to be sunny? So it's pretty easy. You can look it up. The Weather Channel has excellent information and it's scientifically accurate. And then you will submit this to PowerPoint by April 15th, midnight that night. Okay. It is only worth 50 points, but it is 5% of your grade. So don't slack off on it. I know it's the end of the semester. All right, guys. Any questions for me today? Lacey, how about you? Any questions for me today?
No, I'm good.
Okay. All right. Well, then I'm going to end our meeting. I'm going to